All right, we are live. Hello, everyone. Welcome back. I hope you all are doing good. And today we'll be starting off with week 6, that is module 12 on getting started with LlamaIndex. And we have Ravi Teja, who is the data scientist at Glance and is also an open source contributor at LlamaIndex. And apart from that, he was also awarded as top 5 GenAI data scientist by Analytics Vidya. Without further ado, let's start with the session.
Thank you, Taran, for giving a brief introduction. Let me share the screen. Uh, is it visible?
Yeah, it's loading. Yeah, now it's visible.
Full screen?
Yeah, it's visible.
Cool, cool. Yeah. So, yeah, let me give a brief introduction about myself. Hello, everyone. Myself, Ravi Teja, and I work as data scientist at Glance and also an open source contributor at LlamaIndex. And at Glance, I work in building generative AI applications. I even worked on building recommender systems and then some NLP applications as well prior to getting into Gen AI field. And also as an open source contributor at LlamaIndex, I added some evaluation modules and data loaders to LlamaIndex framework and build demos using LlamaIndex, gave talks, conduct workshops, help companies to build onboard customers that can build using RAG systems or agent framework using LlamaIndex. So yeah, let's start with the session. So in this session, I'll be doing a introduction about LlamaIndex, various use cases, and as well as understand the framework, and then in the next session, probably some production ready use case as well we'll see, and then get some hands-on exercise. So let's start with it. Um, to give a context, let's start having a context with it. So LLMs like ChatGPT, OpenAI, Anthropic, or Llama 2, any other LLM are they are very phenomenal piece of technology. Are pretty good for knowledge generation and reasoning. So they're being pre-trained on large amounts of publicly available data, and the cutoff date is 2021, right? And they can perform a lot of interesting use cases like you wanted to write some blog post, it will write a blog post. You ask some question, maybe if it has knowledge, it can give an answer for it. Or if you give piece of text and ask some question on top of it, it will answer it. You give piece of text and ask it to summarize, yeah, it can summarize. You want to go for some trip to a specific place, probably you can plan for it as well. Or else you give all the meetings or some tasks that are available today and ask it to plan for today. It will plan for that as well. Not only this, there are interesting use cases like you want to write code, it will help you write code. If you want to debug some error that happened in your code, it can help you debug as well. So the use cases are endless, and it's a very interesting period to be in the area of LLMs. But LLMs are good, but the knowledge cutoff is 2021. How can you use LLMs do the same task with your own data, which is present across different data sources like SQL DBs or vector stores, Pinecone, Aviate, Milvus, or any other vector store, and APIs, Notion, Slack, and Discord, or even most of the data, private data is present in the raw files like PDFs and PPTs, Excel sheets, audio, video, images, right? So how can you connect LLMs with all these different data sources and perform the same use cases? So let's see some of the solutions that you can work out to compute this task, like attaching LLM with external database, external data or private data, your own data. One way is you have your own data in a Notion document, let's say in a meeting recording call of your daily stand-up call or your product call. What you can do is you have GPT-3 fine-tuning API as well now. So you might have to create your own data set on this Notion document and do an RLHF training mechanism, fine tuning mechanism, and then you'll have an LLM that is fine tuned for your own data. Now you can ask this LLM what is the DEU as per yesterday's product brief. If the yesterday's call is regarding product call, and it can give some answer for it based on the data that you have been trying fine tuning. But then there are some downsides for it. So the data preparation effort is huge since it requires the data in some specific format of prompt and a question and answer. And it might not work well or it may not work well. There is hallucinations that can happen as well with fine after even after fine tuning. And even for fine tuning and using them for inference, there is very upfront cost. And as well, in companies, in very large companies, the documents get created. Let's say the meeting calls happen on an hourly basis, and every meeting call, if you want to have a fine-tuned LLM and in an online learning fashion, it's very hard, right? So updating new data with the LLM is very hard. So since we have so many problems with the fine-tuning approach, let's see other paradigm for inserting knowledge, which is we call it as in context learning. In the earlier case, we have data and we create some format of data and we fine tune the model, right? We change the model there, but we will in this approach we'll fix the model and put whatever data is available into the prompt of LLM along with the question, and then make it answer the question, right? So here there is a product called text, meeting text, and then along with that there is a question with it, and you can the LLM can answer for it, right? So here we fix the model, but we put the context, which is the product brief call, into the LLM, and then make it answer. So what are the downsides for it? Let's say I had 1 hour, 1.5 hour meeting call with it. So it might not fit, the whole meeting call might not fit in the model token limit or context limit. Let's say it is 4K context length model or 16K context length model or 32K context length model. We do have 100K context length model with Anthropic, but still there are studies that it is not attending well in the middle part of the document. Rather, it gives more attention towards the end or start of the uh, document. So, model context limit is a token limit on context limit is a very downside with this approach. And also, what is the right context might be getting the right context might also be a difficult thing. So, these are the key challenges of in context learning. So, how do you retrieve the right context for the given query? And how to deal with very long context, how to deal with source data that is potentially very large, like GBs and TBs. And there is a trade-off between performance, latency, and cost, right? So that's where LlamaIndex as a framework will help you. There are very large knowledge-intensive LLM applications like sales, marketing, recruiting, dev, dev tools, legal, finance, and various other domains. And you have data sources in different format in these domains, and you have foundational model that can do some interesting use cases with Llama Index. So how can you do? How can you connect Llama Index as a framework with LLMs and data sources? That's where the Llama Index as a framework lies in with regard to two things. One is how can you retrieve the right context, and how can you get over with the long token length, right? So let's look into it. How let's look into the framework of it. So in general, so all this comes under retrieval augmented generation, right? So you have knowledge base, and then knowledge base can be, as I said, various data sources from Slack channels, VectorDBs, SQLDB, structured data in SQLDBs, or maybe raw sources like PDFs and all. And then when you have a query, since there is a token contextual limit for all these knowledge base, when given a query, it should we should retrieve the relevant context. When I say relevant context, what is the most probable text that is that can be present, that an answer can be present for this given query, so that the LLM can take this context along with query and generate a response. So this whole framework is called retrieval augmented generation. Given a query, it will retrieve some context from the knowledge base and give it to LLM along with the query to generate an answer. That's why the word RAG, with full form retrieval, retrieving the context, augmenting whatever retrieval context is there, we will augment along with the query to LLM, and then LLM will generate. That is the part of generation. So that's how the name retrieval augmented generation has come for the entire system. So is it clear? Are there any doubts till now? Tarun, is it interactive or it's just
Yeah,
one way?
actually, there is one question.
Hmm.
How is Llama Index different from LangChain? Do we need to cover this now, or can we take this at the later part?
Yeah, I'll take this later towards the end.
Got it. Okay.
Yeah, that's it.
Yeah, as of now, this is the only one question.
Yeah, cool, sure. Okay, I'll cover towards the end. Yeah. So, Llama Index as a data framework for LLM applications. So, so there are primarily three components for it, three or four components to it. One is data ingestion. You have data present in different sources. You can connect them with your existing data sources. And then once you have data ingested with various data tools present in Llama, you index them for various use cases or with an in-memory index or integrate with different DBs. And then you even have a retrieval and query interface. As I said, retrieve the relevant context, the most important part of the whole framework, right? So, and then there is a query interface which will combine the response instance plus retrieval and connecting it to data structures, this index part. So let's see each one of these components individually and understand the whole framework. So starting with first abstractions, we have Llama Hub where there are 100 plus data loaders. Okay, all these different data loaders present in different formats. We have different data loaders for it and use them and get into a document format, right? That's how the data ingestion happens. And then once data is we have read the data from all these different sources, we start indexing. So each document is split into multiple chunks, and embedding for each chunk is created. So let's say I have 3 lakh tokens. I want to have not 3 lakh, probably very huge. Let's say I have a model of 4K context length, and then I have 10K tokens, 10,000 tokens in this document. So I want to chunk the whole 10K into three nodes, right? So three chunks. So 10K by 3 is, let's say, 3,000 tokens. So each node has 3,000 tokens of text. So chunk node 1 has chunk 1 3,000 tokens. Node 2 has chunk 2 next 3,000 tokens, and node 3 has next 3,000 tokens. And maybe we can have node 4 with the chunk for last 1,000 tokens as well. And then for each node, an embedding is also created into it. So whatever these things are created, we create an in-memory index or maybe push into a vector DB. Like works with all different vector DBs such as Pinecone, Bivariate, Quadrant, and Milvus, various other vector DBs. As I said, so once you have a document, Ocean document, we have an Ocean reader, which will ingest this document and then have this vector index, which is simplest form of index in LlamaIndex, which is vector store index. Now, in this vector store index, as I said, given a document, chunking mechanism will happen. Each chunk and along with embedding is abstracted as a node. So there is node 1, node 2, and node 3 stored as nodes in vector store format. Each node is indexed with an embedding in it. So, and then once the index is formed, when a user asks a query, What happens at the backend is it will create an embedding, query embedding. And then since we have embeddings for each of these chunks, what happens is based on this query embedding, it will take, if we take similarity dot k equal to 2, we'll have it will based on this query embedding and embedding of each chunk. It will based on cosine similarity between query embedding and the each of the chunk embedding. It will retrieve top two nodes. Here I have shown node one and node two, but it can be node one and node three as well. And then since these are the most probable nodes where an answer will be present for this given query, we'll send the query and along with these two node information to response synthesis model to generate an answer. So there are a couple of different modes in response in this model. There is refined mode, there is compact mode, and several other modes. So here I will be explaining about refined mode, which is the basic mode in framework. So given a query along with LLM and Node one, whatever text present in the Node one, it will ask it to answer the given query. Sorry, ask it to answer the given query, and then it will generate an intermediate answer. Now I have even node 2 information. So along with the query and intermediate answer and the node 2 information, we'll say I have an existing answer from previous node, and then I have an updated answer, context information from node 2 along with the query. So generate a final answer for it, right? So this is how. So passing through each node, we will generate a final answer for it. So this is a whole framework. There are document sources. We have data loaders in Llama Hub. Use them and then index them to get a high level view of data vectors, keyword, have embeddings, and then summaries, which gives a high level overview of the data. And then we have given a query, it passes through the query engine, and then it connects to the retriever with the help of index. It retrieves the right context or nodes from the index and give it to the responses module, right? And generate a final response for it. So this is the end-to-end flow of the whole framework. Is it? Are there any doubts till now?
Yeah, we have around three questions. I'll start with this one. Isn't it the fine tuning the same as RAG? Can you please tell the difference?
Okay, so fine tuning is something like so you basically create some questions. Let's say here, um, will you what is a Karthik? What is the update? The Karthik who provided update on DAU? Answer will be Karthik. What is growth in last week? Answer will be 3%. And then there you will prepare a data set like this, maybe 1,000 more questions or 100 questions, and then you give this to the model to fine tune. And creating this data set is very hard approach. Like you need to manually go through the document and create it, which is a very manual process. Even though you can use LLM for it, but still it's a very manual process, and using LLM might not be accurate as well. So there is some human in loop required, and also fine tuning is costly. It's not an easy thing, and inference is also costly. It's GPT fine tuning approach. So yeah, for that reason, yeah, we have to go for that approach.
We have one more question. Then we can proceed with the session, I guess.
Yeah.
Retrieval QA took time to process embeddings and generate answers. So using LangChain is a good idea, or training your own pre-trained model is better to get low inference time.
Oh, he's having higher retrieving the time. I didn't get the question.
I've added this question on the screen. Like retrieval QA took time to process embedding and generate answers. So using LangChain is a good idea, or training your own pre-trained model is better to get low inference time.
Um, I'm not sure which index you are using and also which how much long the document is. In general, if the document size is less, probably 10 or 20 pages, the retrieval should be fast enough. It should not be one. So one thing I want to ask is, are you saving the index once it is created, or you are creating index on the fly, creating embedding, and then using as a retriever and generate an answer? So if you save the index and load the index, the inference time will be very less. So yeah, I hope I answered the question. And then, do we pass the text or unique tokens in chunks? We pass text only with X number of chunks limit. Do you maintain the knowledge base error, or do you create embeddings order and then store that in your knowledge base? Yeah, we store the text along with the embeddings. That's what I told. Okay.
Okay, so this particular question is for the vector database, or
Which one?
do you maintain the knowledge base as text, or do you create embeddings of it and then store that in the knowledge base? So this is
You
where
store,
do we
you will
use vector
store
database?
anything with normal vector store index or vector database. We store text plus corresponding ID plus embeddings of that text.
Okay,
Yeah.
yeah, we can continue.
Yeah.
I guess there is one reply for the question on retrieval QA. Saving index and I have less data of about 1 MB, but with GPU also it is taking 40 to 60 seconds to generate answers.
Um, Rather than see, first of all, there is no need of GPU here. I don't know. Are you using local LLM or it's ChatGPT? If it is local LLM, then yeah, it might take some time because of the size of the LLM. If it is ChatGPT, it shouldn't take. Maybe we can connect later after this session. I can look into your code and help you with it.
Got it. Okay. So yeah, we'll continue.
Yeah, cool. So yeah, let's see some interesting use cases with it. Uh, yeah, yeah. Sorry for that. We have some documents that I will be discussing going forward with to explain some of the use cases. So one is Uber 10K filing, which is Uber and Lyft 10K filing. 10K filing with SEC provides an annual overview of the financial things of the companies. So related to revenues, performance, operations, and anything related to finance of the company for that particular year. So, and then I have Paul Graham essay text as well, which is not shown here. Paul Graham is an American scientist, so I'll be showing. I have the document of Paul Graham essay, which he has written from his life journey. And then I have world's billionaires document from which is taken from Wikipedia article about billionaires, which contains both text and tables in it. So let's start with it. So we have the basic use cases QA system. It's a semantic search. So all we have is simple 5 lines of code. You just have data in your whatever PDFs or any other things present in data folder, like, and then you build a vector store index from it, and you make the index work as query engine, and then start querying query engine dot query. Here I have taken Uber 10K filing, and what is the revenue of Uber in 2021? And the answer it gave is 17.5 billion or 17.455 million. So instead of having storing the data in data folder, you can have different connectors. Like I said, there are 100 plus data loaders, like Notion Reader or maybe Slack channel reader or Discord reader, whatever it is. So you can have all this, you can replace this thing and then create accordingly, right? So just hardly 5 lines of code, your QA system is ready. And then one of the other interesting use cases in general is, given a document, I want to have a summarization over it, right? So let's say in the product brief call, there are three nodes. I want to use, so unlike answering some questions where I will retrieve some nodes and then pass it to responses. In summarization, I have to use all the nodes information and then create a final answer. So in those cases, we have list index, or else now it is reformatted as summary index. So given a query along with the node information, we'll ask the query will be provide the summary for the given document. So provide summary for the given document, and then with LLM along with node one information, it will generate a intermediate summary. Now I have an intermediate summary, and then along with node 2, along with the query, which is summary query, it will generate another intermediate summary 2. Now take the another intermediate summary 2 plus node 3, and then query pass it to LLM and generate final answer, which is final summary for it. So this is how a summarization of given document will be created when it is first the nodes are created and then yeah pass it to the through this process. So for that you just need to list index or maybe summary index. Do summary index dot from documents. Sorry, and then make it as a query engine and ask the question, provide the summary. It will go through and provide the whole summary for it. So that's how you can use the same thing for summarization purposes. But in real world, it can be the user query can be a query, either it should retrieve the right context and generate an answer for it, or it can be a summarized question as well. So in those cases, how can you route the user query to specific index? Because in real world scenario, you can't just tell that, yeah, randomly go to both the indices and then create an answer for it, right? So based on the user query, you need to route it to specific indices, right? So how will you do that? So here we have router query engine. So this router query engine will route the given query to either a specific answer, vector store index, or list index for summarization. So what is the revenue of Uber in 2021? So it will route the uh, given question to one of these indices. Like here, the question is with respect to vector store index. It will route the question to vector store index and generate an answer, right? I hope this is clear. Any doubts until this point?
Uh, as of now, nothing. The last question was this one itself.
Okay, cool. Right. And then the other use case is document comparisons. So let's say I have a question, compare revenue growth of Uber and Lyft from 2020 to 2021. So here there are two documents of Uber and Lyft. But instead, if I have the questions like Uber and Lyft and indexed in the same index, it might not retrieve the right context, right? Because of the embeddings approach. Rather than that, what you can do is in a as a human, what you'll do is I'll first get revenue growth of Uber from 2020 to 2021 by seeing Uber 10K filings, and then in the second, I get revenue growth of Lyft from 2020 to 2021 as well, right? And get the answer. Once I get these two answers, I'll consolidate and then give a final answer to it, right? So that's how we have to do even when answering this question using LLMs as well. So how can you do that? You have two indices, Uber for 10K filing and then Lyft 10K filings. Let's see how can you do that. So we have sub-question query engine, and this query engine will create a query plan. As I said, to answer this question, we need to create two sub-queries. What is the revenue growth of Uber from 2020 to 2021? What is the revenue growth of Lyft from 2020 to 2021? So given this query, it will generate two sub-queries. and then for each query, and he'll pass this to respective index and get an answer for Uber and Lyft, and then consolidate the final answer, as you can see here. So this is how a sub-question query engine is useful to compare between both the documents. And then we have in real world use case, we might not always have only text. There can be text as well as tables, as you can see in this particular document, right? So how can you, but if you chunk this document with the tables as well, normal as a normal text, it will lose the whole context or the format of a table, and then it might not give the right answer always. So in those cases, what you can do, let's say if I have a this question as a pandas data frame, and make it work as SQL table, okay, and then on top of that query it, and create an SQL query for it, and probably it can generate an answer for it, right? So the usual process, the good approach is you have separate index for the text, and for tables you make it work as a SQL table and write SQL queries on top of it when for a given question and generate an answer, right? So that's what happens here. So there is a recursive retriever for hierarchical documents. You have an nodes for your text and then index nodes. In each index node, there will be a particular SQL table, or you can say, yeah, all these tables, whatever you have seen here. So when a given question comes, it will go to a particular table, and if it is related to text, it will go to the text and then generate an answer. Or if it is related to the table, it will query the respective table with the help of query engine attached with SQL DB, and then give an answer for it. So that's how you get query with the text and table present in it. And then we have um, so someone was asking, right, how LlamaIndex and LangChain are different, right? So these are some different use cases like document comparisons, and then documents containing text and tables. These are some interesting abstractions that LlamaIndex has. So it deals specifically with the uh, documents, RAG side related things. And then we have text to SQL. So we have a lot of real world data at the enterprise level is on structured tables, right? So you have a table with city stats, and then you can. But we all we all don't know SQL query, right? Especially PM doesn't know SQL query. They depend on analysts or developers. So how can they use this framework and then create SQL queries based on natural language only? So you create a SQL query engine and then start querying which city has the highest population, and then the underlying generated SQL is select city name population from city stats ordered by this, right? So given it text or a natural language, it will automatically convert to SQL, and then a final this query will be sent into SQL DB, and a final answer will be generated accordingly. And then there are interesting use cases like connecting text to SQL as well as your vector database. So let's say I have a SQL DB like population and city, okay, and then I have uh, in a vector database I have all the information related to particular city, and then my query is give me the cultural activities that happen in the city which is fifth populated city in India, okay. So what happens is under the ground it will first retrieve what is the fifth populated city in India, and then once you get, let's say it is Hyderabad, it now the next query is what are the cultural activities that happens in Hyderabad. So since all the information related to Hyderabad is indexed in vector store, it will hit the vector store and retrieve some chunks related to that particular question and generate an answer. So here we have taken Tokyo as the highest population city, and then what are some popular festivals happening in Tokyo, and then it will retrieve automatically and then generate an answer. So in these cases, we can have joint text to SQL and semantic search as well. This is another use case.
Uh, we
Yeah.
have few queries before we proceed.
Hmm.
Are these different kinds of knowledge base already stored somewhere in Llama Index or what? Please, I'm not getting.
No, these are not different knowledge bases. I just said these are the different documents that I am using for this explaining this session purpose only. So I have these documents and then I have indexed these documents, as I said, creating notes and all in the start. So given a document, I have indexed all these documents. That's what I'm trying to say.
Okay. So does query engine have a inbuilt vector database?
So as I said, vector store index is the inbuilt memory in memory index. So and also there is summary index. There is some other in memory index that in Llama index like keyword table index as well. So on top of all these indices, query engine will be built to act it as a query engine. Okay. So you can even store all these documents in vector database, which is not in memory but cloud-based thing. And then on top of this vector databases, also you can create a query engine as well. So queries engine is another abstraction on top of either vector store index or in memory indices or vector database as well.
Okay, so I have one question related to this one itself. Like as you said, it will be stored, right? So in the query engine or indices which you mentioned, so are we storing the memory or just the appendix part?
Now we are
So what
storing
exactly?
everything in memory. For vector store index, we'll be storing embeddings and text, other metadata information in memory.
Okay, so after we pass the loaders or data, then next we have the chunkers or indices. Then do we have embeddings or embeddings is already part of the indices? Is it the
Embedding
next
is
process or
part
the
of,
same?
embedding is part of indices.
Okay, got it. Yeah. And this is the last question which we have before we can proceed. Like, where can we use the concept like re-rank here? Can you please show the implementation? Should we
Yeah,
take this or
yes, sure. Let me take it. So, re-ranking is another concept. So, once you retrieve the context from the given document, let's say I retrieve top 10 checks, and then on top of that, I want to re-rank, maybe cover re-rank or sentence transformers re-rank model, anything. So on top of that, if you want re-rank, after retriever, you have a re-ranker module, and then on top of that, you can build a query engine. That's how the flow is. So today's session is not on the implementation side. I can show the whatever implementation regarding re-ranker is there in the next session next week, like 23rd, and then yeah, we can go through it.
okay? So yeah, we can go ahead.
Yeah, cool. Yeah. Is it visible? Blog post.
Yeah, it's visible. Notifications is visible as of now.
Cool. Okay. Yeah.
Yeah, Llama index
Yes.
yeah, it's
Yeah.
visible.
Yeah, cool. So here, see in the companies we have like Amazon or Flipkart or any other company, we have text to SQL and sorry, we have product reviews for each of the product for each and by each user, and these product reviews will be coming in an online fashion on in every day. So how can you analyze these product reviews from the users so that PMs or anyone can understand how the products are functioning, right? So, so here I have taken a use case like how can you analyze product reviews? Uh, so I have created a data set for let's say three products like iPhone 13, Samsung TV, and some ergonomic chair reviews. So we have category, product name, and review for it, right? And then so what we do is we keep these whatever data set I have created is into a SQL DB, okay? And then let's say I want to achieve something like how is the sentiment of Samsung TV product, or are people happy with the ergonomic chair? So let's say I want how is the sentiment of Samsung TV product? How can we achieve this? So first of all, to get the sentiment, I want to know what are the reviews of this product Samsung TV, right? So so we need to create first the query is how what are the product reviews for Samsung TV, right? And then after that, once the product reviews are given, your next step is what is how is the sentiment of these product reviews on Samsung TV product, right? So these are the two sub questions that we need to create. So for that, I have created a function generate questions, and then I have told that this is the table available city name, population, country, and reviews, and then it will generate two queries: text to SQL query and the RAG query. So text to SQL query, as I said, what is the product reviews for this particular product, Samsung TV. So given that query and the table is already inserted, we'll have a response with all the product reviews. And once we have product reviews, we can dump this product reviews in the list index, because list index is for summarization purpose and it goes through all the chunk available. So on top of this, you can have this RAG query, which is what is the sentiment of Samsung TV product reviews, and then it will generate an answer for it. So that's how you can combine text to SQL plus RAG list index for analyzing the product reviews. So this is another interesting use case that you can build with LlamaIndex. So yeah, so what we have learned here is building QA systems, connecting through multiple indices, document comparison techniques, and then if you have text plus tables, text to SQL plus RAG, application and demos. There are a lot of other things like evaluation, metadata management, fine tuning with RAG, and how can you log or trace all this, what's happening under the hood. And there are agents, separate agents framework as well under LlamaIndex. So there are even principal practices for RAG systems, which are helpful in building a much enriched RAG system. So you can all go and check with it. Yeah. So yeah, that's what I have for today's session. Next session, I'll probably go through some notebooks, and as someone asked, re-ranker as well. I'll have that demonstration in live session format. Yeah. Any questions? I'll be happy to take it.
Okay, so this one was the last one,
Yeah.
and I have
Yeah.
added the
Maybe
blog article.
yes, I'll share. Yeah, even have I forgot to show some applications. I will just share it probably.
Okay, I have attached the blog article which Ravi was showing right now on the RAG analysis on the product reviews.
Yeah, I'll just share this deck. Can you share it, Tarun? Because I'm unable to share it in
Yeah,
common.
yeah, I got a link.
Yeah. So this particular use case is often we read novels, right? But we read probably first 10 pages or 100 pages, and then we leave the novel, and then go to another book, or maybe even take some other break, and then after 1 month come back to the novel. And by this time, I'll forget what I actually read in the book as well, and characters or what happened till now. So how can these guys build a frame app to serve this purpose? So a document is being loaded, and he went through probably six chapter, and then now in the sixth chapter, for first five chapters he might have read, and then he just add this text, and then he has three questions recap until now. What was his character done in last few pages, or fetch history of this character. So this will give you the answer for it, and then and yeah. So yeah, that is an interesting application using LlamaIndex framework. And then there's a company called Albus, which is using LlamaIndex to uh, for HR people on Slack. They can upload the documents, and they can ask some questions, and then it will generate an answer, give an answer based on the source whatever we have, right? So yeah. Those are these are some companies. LlamaIndex is being used over video works, Albus, and Meta. Then I'm conducting a workshop on September 29th at PyCon India. You can all register and see if you want to explore much more features. Yeah. Any questions, I'll be happy to.
So we'll wait for a few questions. If you have any question, please feel free to ask. And just to give an update on 23rd live session, we will continue with the Llama Index. And today, Ravi discussed about RAG and more about the knowledge base. And on the next session, you will be working on the notebooks part, and you will learn retrieval augmented generation in more detail. So that is for the next module, which is module 13 on RAG. Okay, I guess there are no more questions. If we have any more question, we can cover that on 23rd live session. If not, you can ask those questions in the Discord channel. We will be covering those in the starting part of the next session on drag. And yeah, we'll be sharing the resources as well, the slides. And you have two articles over here. One is what it was already shared, and this particular document. Okay, there is this one question like, have you
Have
worked
you
with
worked with
private
private
GPT?
GPT? I personally did not work with private GPT.
Okay. Please feel.
Also,
Yeah.
and also please feel free to reach out to me on LinkedIn or Twitter or yeah on Discord. Happy to help. Does Llama Index work offline? Yeah, so it's all LLM part, right? If you have we have connectors with Llama CPP or GPT for all or Llama 2. If you have deployed it in on some replicate or something Llama 2, you can connect with Llama 2 and make it work offline as well. Yeah.
Okay. So, do we have any more question, or do we end this session? We'll wait for 1 more minute, and until then, if you have any closing thought on best practices to implement when you are getting started with Llama Index. So, we'll have 2 minutes buffer time until we have few questions.
Yeah,
So,
sure.
the
So
best
yeah,
practice.
whatever I mean, best practices, and then evaluation or uh, can we have a demo session on Llama CPP? Okay, I'll try to do that in the next session probably. Let me see if I can do it on my laptop. Yeah,
There is this one question like, can we have a demo session on Llama
yeah,
CPP?
that's what I replied for. So I'll try to see if I can include that in the next session, or else I'll share the notebook where you can go through it.
Okay. If it's a notebook, then we'll add that in the notebook session of the. You can check out AI Planet LLM Bootcamp. We have every module. For each module, we have tutorial, we have notebook, and we have session. And if there is any resource, I mean notebook. If the notebook is shared during this talk, then it will be added as a notebook session. So you can refer that for Llama CPP. All right, right? It's notebook, right?
Yes, yes, I'll share it in the coming 23rd session.
Okay.
Yeah, on the best practices side, probably we need to. I'll cover them in some things in the next session where we can discuss. Yeah.
All right. So yeah, I guess that's it from the question side. And once again, thank you for accepting the invitation and sharing your knowledge on LlamaIndex. And we'll see you soon, and we'll learn more about retrieval augmented generation. Yeah. Thank you, guys. Thank you for joining, and
Thank,
keep learning.
thank
Thanks.
you.